Hello, guys. Can you hear me? Hello? Can you hear me, guys?
Yeah,
How are you guys doing?
good. How about yourself?
Fine, thank you. Miss Antoine, I think you missed the test, right?
I just did it.
Okay, you submitted it now. No,
Mm-hmm.
I'm talking about Antoine. Antoine, yeah, you say you just did yours now?
Mm-hmm.
Okay.
I,
Joseph, how
I
about
had
you?
one question though.
Yeah.
What was table one for question 6?
Yeah, he's taken care of. It's an omission. Just you'll be graded on 5 questions, not 6 questions.
Okay, that's what I thought. I was just making sure.
Yeah, I omitted. It was an omission on my side.
Okay,
Mm.
sounds good. Yeah, like I
So,
said, I just turned it in.
yeah, yeah.
I, I just turned it in.
Okay, very good. So now, so we have Miles is in here now. Joshua is in. I have Herod. I have Antoine. 1, 2, 3, 4. Okay, I think it's who make 1, 2, 3. Yeah, who else? Oh, got it. Okay, we can begin. Actually, today is just a revision of what we did this week. This week mainly we focused on the process strategy as it relates to um, financial operations, financial analysis for operations. So we will look at how we can apply some of the financial analysis to operations, and it, especially as it relates to choosing the kind of project or investment to undertake. So that's what we covered this week, and I want to review that. We'll start with the capital investment and cash flows. We discussed that in the class. Yeah, in which during that time I explained that evaluation of investment alternative will require us to consider the initial investment plus the cash inflows and cash outflows. Also, we need to consider depreciation and taxes over the economic life of the project or asset. Now, net cash flow, like I explained in the class, simply means the difference between the cash coming in, which we call revenue, and the outgoing cash, which we call expense. So we often express them in present value terms. I hope you can see my screen. Yeah, I have it right here. Yeah, good. Now, before we proceed, I will also review what we said about time value of money. The time value of money concept. Under this concept, money, we see, the way we say it is that the cash or money that is available today is worth more than the one that will be available tomorrow or next week or next year. What does that mean? That the cash available today is more valuable than the same amount of cash available at a later date. Why is that? Because let's say that the money, the cash in question is says $20,000. If you have it today, if you're given the choice to have the money today or to have it in 2 years' time, even next year, in 1 year's time. Now, if you have it today, you can invest it in some, maybe in a stock or some asset that by this time next year, it will increase the money, the amount through the returns on that investment. Or even if you do not invest it, as we all know, the money loses value over years due to inflation. See? So that 20,000 you have today may be less than 20,000 you have by this time next year. Okay? So that is the principle behind the time value of money. What you have it earlier, you can invest it and accrue some cash flows and before they get to that future time. Or the value is what it will be worth more today and than in the future because of the inflation, the pressure of inflation. Okay. Now the difference between the present value P and the future value F of the money is usually due to the accumulated interest over the number of period N. So I also presented to you this formula for finding the future sum or total amount due, which is F equals P times 1 plus I to the power N, where P is the principal, F is the future sum, and number of period is N, and I is the rate of interest. You know, some of these things you're going to see it on the second test 2, which I might have for you next week or the week after next week. Okay. Now, for this one, we did an example of this type, where we say that we are asked to find the principal and the interest due at the end of 2 years if $1,000 is borrowed at a rate of 10%. I mean, we can look at this one again. The principal is given is 10%, and what is $1,000? Okay. And number is 2 years. And interest is 10%. 10%. Want to use this formula, you can just plug it in and you get your results. And I had it here when you put this on the calculator to give you the answer. Let's say 100,000, 1,000 times 1 plus 0.1 raised to the power 2, which you can do this in Excel or you can just use your calculator. I think I have this free calculator they have online that I usually ask my students to use sometimes if they prefer to use online calculator. So you have it. If you can see it, I'm sure you can see the screen, right? Hello, guys. You can see the screen, right? Hello.
Yes, we can see it.
Okay, good. I mean, if you want to use calculator for this one, because it's a simple formula, you know, you're giving all this information. So 10% is 0.1. So, and if you plug this information into this simple formula here, P times 1 plus I to the raised to the power N. And if you put that in this calculator, you're gonna have say 1,000 times 1 plus 10%, which is 0.1, raised to the power 2. It gives us $1,210, and that is what we have on the let's see right here. So that's the one we did I think on Monday, either on Monday or Tuesday, on Wednesday, I can't remember exactly. But I think that will give you an idea of what I'm talking about. But we usually like to use the present value method. Net present value method, where we make most investment decision by calculating the present value of a series of future cash flows, and then we use this formula. PV, which is present value, equals F over 1 plus I to the power N, where the F is the future value, P is the present value, I the interest rate, N is the number of years. Now, usually Excel is better for this one. As a way of understanding what we are doing, it is also very necessary for us to be able to figure out what the present value concept means. Simply put, the present value concept tells us how much future money, how much money in future is worth today. Now, given that money loses value over time due to inflation, and also given that if you have money today, if they give you, if you're asked to be given an amount of money today, or to be given that same amount next year, and if they to give you next, what is worth today will be more than what is worth next year, because of course inflation, also because of the missed investment opportunity because if you have it today, you can invest it. By the time you get to this point next year, the value will increase. So because of that, we use present value to show what future earnings or savings are worth today in dollars, or what in today's dollars. So I did this example last time, and I think on Wednesday. I put this on Wednesday. So I want to repeat it again. Remember, this is just a review of what we did this week. So this one is one we did on Wednesday. We'll come to it eventually. But another thing we did was I think I missed it. Okay, I think I missed it. That's one we did one I missed. Okay, let's do this one, then we'll go out and make a flashback to that one. It says the Riverfront Bakery is considering investing in a new bread making machine. Okay, and the machine will generate $200,000 per year in profit for 5 years. So determine the present value of this cash flow. Assume that the interest rate is 5.2%. Okay. So what you're gonna do is to put this in Excel. It will simplify the work for us. Let me write down the numbers. Now you see, generating $200,000 per year in profit is a revenue that come into the company. But for those customers paying this money, it represents money leaving their pockets. So for them, for the company, it's a positive cash flow. But for those customers paying this money, is negative cash flow. So when we put this in Excel, we have to represent the direction of the cash flow by using the correct signs. For this one, I'm going to use negative 200,000. So let me write this down. For the solution, I'm going to say C Excel solution. Okay, I'm going to say C work in Excel. Work in Excel. Okay. Now I'm gonna put this in Excel and have let me write them down. Payments that we still receive, PMT be 200,000, and of course the rate is 5.2%, and then you have the number of years N is 5 years. Okay, 5 years. It's gonna be 5 years. So we can go and put all this in the Excel, and I'm gonna take you there now. What is it right here? So making this bigger, I'll make it 14, so you can even 16. Okay, good. That's better. Now I have this interest is 5.2%, which is, let me make sure I've seen this. 0.052. 5 years. Payment they're receiving is 200,000. So to represent the direction of the flow of cash from the customers to the company. Cost for the company is positive cash flow, but for the customers, it was money leaving their pockets. It's negative cash flow. Total now becomes negative 200,000. And the future value, we don't know the future value. They didn't tell us. Type is at the beginning of end of the period. So put 0. So now let's put this put the present value computation. You can see the formula right here. By your left, by your right. Equals PV present value. So now, before I do that, let me remind you of the direction of the cash flow again. When you're taking you back here, you can see here. When you use Excel, time value calculation, you must enter the sign that corresponds to the direction of the cash flow. So I've already explained that. Now for type, this is use ordinary, end of the period, use 0. So I've already explained that. So let's go back. So present value, it pops out, double click, interest rate, comma, number of years, comma, payment, comma, future value, and then type, end of the period, 0. Close it, and then press the enter key. It's what 861,000 say 861,128.98. Any questions on this? Any question, guys? Hello.
No questions.
Okay, good. Now, that is the present value for you. Now, the there's another method we use. We call it the give me 1 minute. Expected monetary value method. We discussed that on Monday. I think we talked that it's called this on Monday. It's called the expected monetary value. So in this case, we specify the alternatives and then and various state of nature. And based on that, we can generate or we can assign probabilities to the different outcomes for the project or or investment. Based on that, we can calculate the expected monetary value. After that, we can choose the investment that have a higher more expected monetary value as the correct one. So for the expected monetary value calculations, the way I explained it last on Monday, we use this formula here. Excuse me. Expected monetary value may be sum of x times the probability of x. Of course, that probability will be assigned to the different state of nature with respect to that project. So we did an example here with the Southern hospital supplies. The one I'm going to use today will be a different example, but with the same concept. It's for the Brick Company Limited. Okay. So it says here that the Brick Company Limited, a company that makes manufacture high quality bricks, is considering expanding its production capacity to meet the increasing market demand. So the company is evaluating 4 options. The first option is to do nothing. So that means nothing change. The second option is to build a small factory. Then the third option is to build a medium factory. Then the fourth option is to build a large factory. Now, each new facility will produce specialized line of eco-friendly products, which is bricks. But the demand for these products is uncertain. So if brick company build a large factory and the market turns out to be favorable, the company expect to a profit of $200,000. But if the market is unfavorable, they will face a loss of $150,000. A medium factory will result in a profit of $100,000 if the market is favorable. Otherwise, they will lose $30,000 if the market turns unfavorable. The small factory will generate $60,000 profit under favorable condition, while on the unfavorable condition will cost them to lose $5,000. So as always, of course, they have the option of not doing nothing, in which case they gain nothing and lose nothing. Okay. So now the recent market analysis suggests that there's a 0.6 probability of a favorable market and a 0.4 probability of an unfavorable market. So your job here is to help Brick Company Limited to determine the best option by selecting the alternative that provides the highest expected monetary value. So this one, first of all, we put this on the calculator. Remember, the formula is to use the profit, of course, times the probability of that profit. Now, I have it here in the Excel, the formula and what we can put in. You can see X times the probability of X. Okay. Now, for both of them, for both favorable and unfavorable condition. Now, I'm going to make this a little bit bigger. Okay. Now, you can see this. Okay. Make sure. All right. Now, when we go through the question again, it says, if the company build a large factory, if a favorable market is favorable, they make $200,000 profit. Okay, that means for a large factory, for under favorable, we put $200,000. But if it's unfavorable, okay, they lose $150,000. So I'm gonna put $150,000 there. Minus $150,000. Okay. Now, if they build a medium factory and the market is favorable, they make $100,000. But if it's unfavorable, they lose $30,000. So for that, we're gonna have under favorable, they make $100,000. But if it's unfavorable, they lose $30,000. Okay. Now, just build a small factory. They make $60,000 profit under favorable market condition. But if the market is unfavorable, they lose $5,000. So this one gonna be for small plant 60,000. But if it's unfavorable, they lose 5,000. Now, if they do nothing, they get nothing and lose nothing. So the probability, according to the question, the probability of the market becoming favorable is 0.6, and the probability of unfavorable is 0.4. Okay. So we're gonna put it right there under probability to have it here. Okay. 0.6. Sorry. For favorable is 0.6. But unfavorable is 0.4. Okay. Now you can now calculate the expected monetary value. Remember, the one that have the highest EMV is one that you choose. So let's calculate it for this one. Remember the formula X times PX for both of them equals, you got 60,000 times 0.6. Close it. Then plus negative 5,000 times 0.4. Okay, that gave me the expected monetary value for that year. Let me remember these are all money, so I'm gonna make it dollar sign. Okay, I'm gonna okay. Okay, good. Now repeat the same process for this one. Equals we have for the favorable we have 100 times 0.6. Okay. Now unfavorable for this scenario will be negative 30 times 0.4. Okay. For 8,000 for medium plants. And for the large plants, we have the same thing. 200,000 times 0.6 plus for the unfavorable, we have negative 150,000 times 0.4. Close it and enter key 60,000. Okay. Now for the do nothing, of course, you gotta be 0. Now, so now you can see all the scenarios. Now, based on that, you can see that this one, large plants have the highest expected monetary value. So brick companies should choose to build a large plant because it have the highest expected monetary value. Now, any question before we leave?
I have no questions.
Okay, good. So in that case, I'll see you guys on Monday then. Enjoy your weekend.
Enjoy your weekend, Professor. Have a nice one. Thank you.
You too. Bye-bye.